Example 2, state the x and y intercepts of y equals 1 over 6 minus 8. So we just want to review finding x and y intercepts when we have a reciprocal function. To find the x-intercept, remember that you're going to let y equal 0. So I'm going to put 0 in for y, and now I'm going to solve. So I like to cross multiply. So maybe picture that as a fraction. So I get 0 times 6 minus 8. Well, anything times 0 is going to be 0. And equals 1 times 1 is 1. Well, what happened here is that I don't have a variable anymore to solve for. And I also have a statement that's not true. So I have to put a not equal to sign in there. 0 does not equal 1. How am I solving for x? Well, this is going to happen. The algebra is going to work out that way when you actually do not have an x-intercept. So there is none or no x-intercept. Because if you remember that on a reciprocal graph, you're going to have a horizontal asymptote at y equals 0, which means that there is never going to be an x-intercept for the reciprocal graphs that we are going to draw. There is when we move graphs around later on. So we're going to say none. So make sure you know why. It's because you have a horizontal asymptote at y equals 0. So that's the reason. The algebra supports the reason, but it's important you understand that the reason why is there's actually an asymptote. The graph is never going to touch across the x-axis. Let's look to see what happens if we have a y-intercept. For the y-intercept, you're going to let x equal 0. So y is equal to 1 over 6 times 0 minus 8. So y is equal to 1 over negative 8. And so y is equal to negative 1/8. So you will have a y-intercept when you're graphing reciprocal functions.